Well, hello, 8-bit physics students. I know what you're thinking. You're thinking to yourself, Mr. Kirsten, we just learned about these vector things, right? But these vectors are just mathematical objects. What can we do now with these vectors? Well, I'm glad you asked, AP Physics students. Let me tell you what you can do with these vectors. All right, vectors take us into another realm, from one dimension into two dimensions. And now that we know about mathematical tools of vectors, we can enter this second dimension and study, dun dun dun, projectile motion. And that's really what section 3.5 and 3.6 from your reading is about tonight. Projectile motion. What is projectile motion? It's two-dimensional motion, so an object's moving in two dimensions at once, maybe up and down and side to side. And it's two-dimensional motion where only gravity is at work. Okay? So if you think about like a circus performer getting shot out of a cannon, right? While the person is in the barrel of the cannon, that is not projectile motion because there's something besides gravity acting on them. Whatever spring or explosion or whatever it is that shoots them out of the cannon. But once they leave the cannon, then they're in projectile motion, because once you get shot out of the cannon, once you leave the cannon, the only thing influencing you is in gravity. You may have had some initial speed or something like that, but gravity is the only thing working on you. So typically in projectile motion, we're going to ignore things like air resistance and things like that. And yes, okay, so projectile motion, two-dimensional motion where only gravity is working on you. Okay? Okay, so up until right now, we have had three main equations when dealing with kinematics, or three equations that describe one-dimensional motion. Now, here is the secret to two-dimensional motion. Are you ready? Here we go. Two-dimensional motion is really two separate one-dimensional motion problems. So just break every two-dimensional problem up into two different one-dimensional problems. What do you mean by that, Mr. Kirsten? Well, take each of these equations and turn it into two equations, one in the x direction, one in the y direction. So let's look at this first equation. Final speed equals initial speed plus acceleration times time. Really what that means is final speed in the x direction is equal to initial speed in the x direction plus the acceleration in the x direction times time. Or in other words, final velocity in the vertical or y direction is equal to initial velocity in the y direction plus acceleration in the y direction times time. Since this equation is true, these two equations must be true, because motion in one coordinate system is independent of the other. All right? And likewise, you can take the other equations here and split them up. So you might say that your final y position is equal to initial y position plus your initial velocity in the y direction times time plus 1/2 the y acceleration times time squared. Okay? So every projectile motion problem, every two-dimensional problem is just a one-dimensional problem, taken two at a time. All right? So we are going to take these equations and split them up, and now these equations were your best friends up until now. Now these equations are your best friends. Really, it's twice as many equations, but it's the same equations, just in two different coordinate systems. Mr. Gerson, I didn't understand a word you just said. How about we do an example problem as an example of what is going on? All right, let's dive right in here. Oh, hey, that was a little joke there because it's about a diver. All right, we're gonna start in on problem 19 here as soon as I find my pen. And pardon me, did I say 19? Problem 18. Problem 18 says there is a cliff diver, and this cliff diver is running straight horizontally and dives off of the cliff going 1.8 meters per second. All right, he dives out, and I'm just going to sketch in the path that I would guess that the diver would take. Turns out that is a parabolic path, but you're going to read all about that. Okay? And it takes 3 seconds for the diver to hit the surface of the water. And we want to know, one, how high up is the cliff that the diver jumped off of, and how far over will the diver land. Well, in any good problem, it's good to define a coordinate system. So I'm going to put my origin right here, and just so I know what in the world I'm talking about, I'm going to put a little plus x and plus y. So from now on, this is the plus y direction, this is the plus x direction. Okay? That's my coordinate system. So step 1, set up a coordinate system. Okay, step 2, let's write down what we know or what we don't know. Let's start with the y variables. What is my initial y position? I don't know. That's one of the things I want to find out. What is my final y coordinate? Well, when I hit the water, my final y coordinate would be 0. My initial speed in the y direction, that is 0 also. But Mr. Kirsten, I thought the guy was running really fast right before he jumped off the cliff. Well, that is true, but since he's jumping straight horizontally, that motion is in the x direction. So I'm just going to jump over here right away and say I know that Vox is equal to a plus 1.8 meters per second squared. All right. Final velocity in the y direction, that would be how fast he's moving in the y direction right before he hits the water. I do not know that. But I do know that the acceleration in the y direction is a negative 9.8 meters per second squared. Again, we're assuming this guy is a projectile, he's in free fall, ignoring air resistance, that type of thing. So he's going to be accelerating downward at negative 9.8 meters per second squared. Okay, how about our x variables? Well, I know that he starts at the x coordinate of 0, right? So he starts right there. Final x, I do not know. Vox, we said, is 1.8. Vy, we are not sure of. But I do know that the acceleration in the x direction is 0 meters per second. Why is that? Well, once he leaves the cliff, the only influence acting on him is gravity, and that's going to pull straight down, right? Gravity doesn't pull side to side. So while he's moving horizontally, he's not accelerating that way. All right. So I've got my y coordinates, I got my x coordinates, and then this is just me, variables that affect both x and y, like angles or time. I kind of like to put in their own little section here. So I've got x variables, y variables, and some variables that affect both. Time is the same in both dimensions, or at least until we study special relativity that Albert Einstein discovered in 1905, which says that space and time are actually related to each other and bend and warp in on each other. But that's another video. Okay, so for us, time will be the same in both coordinates. Okay, well, this is what I know. Step 1, the question 1 was, how high is the cliff? Well, I want to know how high the cliff is. That would be why not, right? So I've got one of two variables, one of two equations to choose from. I don't know what Vy is, so I'm going to use this equation to solve for why not. Why am I doing that? Why not? Y equals why not plus Voyt plus 1/2 Ay t squared. 0 is equal to y naught plus Voy is 0, so 0 times 3, which is just 0, plus 1/2, negative 9.8 times 3.0 squared. And if I wave my magic algebra wand at this, I get that y naught is equal to a plus 44 meters. All right? All right, not too bad. Part B, And that's how high up he starts. So this is 44 meters here. Right? Okay. The second part says how far does the diver end out up here? So what is final x here? All right. Well, I have two equations with final x in it here. And I'm going to use this one. Okay. So that would be x is equal to x naught plus voxt plus 1/2 axt squared. So final x is equal to 0 plus 1.8 times 3.0 plus 0, because ax is 0. And therefore, final x is equal to 5.4 meters. All right? And we'll just highlight that answer there. All right, nice job, AP Physics students. That is problem 18, two-dimensional projectile motion. And for your hard work today, I got a joke for you, all right? It's what do you get when you cross this with a this joke, right? Okay, here we go. Ready? Okay. What do you get when you cross the Atlantic Ocean with the Titanic? About halfway. Which actually, when you think about it, the people who died on the Titanic, maybe that's not a good thing to laugh about. I mean, I guess it's 1913, but I don't know. Too soon? Is it too soon? Too soon to make Titanic joke? Anyway, all right. Good work. We'll see you tomorrow, AP Physics students.